The Deutz MTZ 320 tractor, manufactured in 1932 by Deutz Motoren AG in Cologne, Germany, is a remarkable example of early diesel engineering. Powered by a two-cylinder flat water-cooled Deutz diesel engine, it delivers 37 horsepower in traction and 40 horsepower at the pulley. This robust and efficient machine was designed to meet the demanding needs of agriculture in the early 20th century, offering excellent reliability and power for plowing, threshing, and other field operations. Its advanced diesel technology made it one of the pioneering tractors of its time, symbolizing Deutz's commitment to innovation and mechanical excellence. The Komatsu International Tractor Type D219, produced around 1965, represents a collaboration between Komatsu Limited of Japan and International Harvester of Germany. This 19-horsepower tractor, operating at 1/900 revolutions per minute, reflects the engineering style of its era, featuring German-made instruments and durable Otsu tires, later part of Sumitomo Rubber Industries, known today for Falcon Tire. Manufactured jointly in Neuss, Germany, and Tokyo, Japan, the D219 embodies the technological exchange between the two nations during the 1960s. This rare model was displayed at the 2014 Karuizawa Engine Show, where it drew attention for its historical and mechanical significance. The Kiawa engine, produced in 1950 by Kiawa Farm Machine MFG. Company in Otori Higashimachi, Nishiku, Sakaishi, Osaka, Japan, represents a fine example of Japan's post-war agricultural engineering. Rated at 3 horsepower and operating at 800 revolutions per minute, this compact single-cylinder engine was typically used to power small tillers and other light farm machinery. Its design reflects the technological simplicity and practicality of the time, when Japanese farmers were transitioning from manual labor to mechanized cultivation. The Kiawa engine functioned by driving a dynamo that generated electricity for the igniter, which in turn provided a spark to the spark plug. This reliable ignition system allowed the engine to operate smoothly and efficiently, even under rural working conditions. Despite its modest power output, it played a vital role in boosting productivity and modernizing small farms across Japan during the 1950s. This particular engine was not owned by me, but was observed at the 2014 Kochi Miyanamai Engine Show, where many vintage engines were exhibited. The Kiawa engine stands today as a nostalgic reminder of Japan's mechanical ingenuity and the early evolution of its agricultural machinery. This is a 1500 kW Cummins diesel generator set, manufactured in 2008, currently undergoing load bank testing to verify its full operational capacity. Designed for standby power applications, It delivers 277 480ths volt output with remarkable reliability. Despite its age, the generator has only 377 hours of operation since new, reflecting minimal use and excellent condition. The load bank test ensures that the generator can handle maximum electrical loads safely and efficiently, confirming both performance and durability. Such a robust and well-maintained unit is ideal for critical backup power applications in industrial or commercial settings. The old engines in Japan 1920s Edwards engine 6 horsepower represents a remarkable example of early 20th century American engineering that found its way to Japan during the era of rapid industrial development. Manufactured by the Edwards Motor Company in Springfield, Ohio, United States, this two-cylinder engine was among the finest examples of small power units designed for agricultural and light industrial use. It was capable of producing between 1.5 and 6 horsepower, operating at 600 to 100 revolutions per minute, with a bore and stroke of 76.2 millimeters by 127 millimeters, resulting in a total displacement of 158 cc. In 1922, the Edwards engine was imported to Japan by Kyoko Company, which maintained a branch office in New York and served as the general agency in Japan and Manchuria. This event marked a key moment in Japan's early adoption of Western industrial technology. At that time, the Edwards engine was priced at 570 yen, a considerable sum equivalent to over $16,600 in today's currency, reflecting its advanced quality and rarity. The Edwards engine became known for its reliability, smooth operation, and durability. With its compact yet sturdy design, it powered a wide range of machinery such as pumps, small generators, and agricultural equipment. Its twin-cylinder configuration provided more stable power output compared to single-cylinder models, which made it especially valued in industrial workshops and farms seeking dependable performance. In Japan, engines like the Edwards symbolize the transition from traditional manual labor and steam-driven equipment to more efficient internal combustion power sources. The introduction of such machines contributed greatly to modernization, especially in rural and mechanical industries. Today, the surviving Edwards engines are extremely rare, treasured by collectors and engine enthusiasts. When restored to working condition, they vividly demonstrate the mechanical ingenuity of the 1920s and the international exchange of technology between the United States and Japan. The 1920s Edwards 6-horsepower engine thus stands not only as a piece of machinery but as a living artifact of early global industrial history, embodying craftsmanship, innovation, and the spirit of technological progress. The Sulzer two-cylinder diesel engine with pneumatic injection is an impressive example of early large-scale industrial engine technology. Built with a total weight of about 15 tons and an output of 100 horsepower, this Sulzer engine represents the robust engineering standards of its era. Designed for stationary or marine applications, it uses a two-cylinder configuration that ensures balanced power delivery and reliable performance. What makes this engine particularly remarkable is its pneumatic fuel injection system, which was a pioneering feature at the time. Instead of using mechanical injectors, compressed air was employed to atomize and inject the fuel into the combustion chamber, resulting in efficient combustion and smooth operation. The engine's massive cast-iron construction and meticulous craftsmanship reflect the Swiss precision associated with Sulzer's reputation in diesel technology. Even today, preserved models of the Sulzer pneumatic injection diesel engine remain fascinating to mechanical enthusiasts and serve as valuable reminders of the evolution of heavy-duty engine design in the 20th century. The Van Renns petroleum motor, built in 1906, was an early internal combustion engine used aboard the motor freighter Vorwärts 1. This historic engine represents one of the pioneering steps in marine propulsion, running on petroleum instead of steam. Its design combines simplicity with durability, featuring a slow-running single or twin-cylinder layout typical of early 20th century engines. Installed on the motorboat ship Vorwärts 1, it provided reliable power for inland shipping, marking a transition from sail and steam to motorized transport. The Van Renns engine stands as a fine example of Dutch engineering innovation in maritime history. The Deutz RBV 6M 545, produced in 1962 by the renowned German manufacturer Deutz AG, is a powerful six-cylinder, direct reversible marine diesel engine. With an impressive output of 750 horsepower at 380 revolutions per minute, this engine represents a combination of durability, reliability, and robust engineering typical of Deutz's marine power systems. Designed with a V-type configuration, the RBV 6M 545 delivers balanced performance, efficient combustion, and excellent mechanical strength. One of its notable features is its ability to operate on heavy fuel oil, a characteristic that made it suitable for large vessels and industrial machinery of its time. Its direct reversible mechanism allows ships to change direction without the need for a separate gearbox, a valuable advantage for marine propulsion systems operating under demanding conditions. The Deutz RBV 6M 545 was widely installed in cargo ships, fishing trawlers, and auxiliary vessels, where reliability and ease of maintenance were essential. Despite being over 6 decades old, many of these engines remain operational today, a testament to the superior build quality and long lifespan of Deutz designs. Spare parts and technical support are still provided by specialized suppliers, helping to preserve these classic engines in working condition. Overall, the Deutz RBV 6M 545 stands as a remarkable example of early 1960s marine engineering, efficient, rugged, and built to last. It reflects Deutz's long-standing commitment to producing high-performance engines that continue to serve both industrial and maritime needs worldwide. This 2,000 kilowatts Caterpillar diesel generator, often equipped with a Cat 3516 TA engine, is a robust industrial power solution, delivering 2,000 kilowatts of real power and 2,500 kVA apparent power. It ensures reliable performance for standby, prime, or continuous operation. Designed to handle full rated load in a single step, it operates at 1,800 RPM for 60 Hz or 1,500 RPM for 50 Hz, accommodating various voltage requirements such as 480 volts. With its large 16-cylinder, 4-stroke engine, this generator is ideal for mission-critical applications, providing consistent, high-capacity electricity wherever dependable power is essential. Inside the old sawmill in Linghead, time seems to stand still. Wooden beams, darkened by age, surround a magnificent piece of early industrial engineering, the Bolander sawmill. Built with robust iron and heavy gears, this water-powered or belt-driven machine represents the craftsmanship of a bygone era when power and precision were achieved through pure mechanics. As the sawyer prepares the log, he uses a hand lever and carriage system to secure and move the timber into position. The large pine trunk, stripped of its branches, rests on a steel cradle that rolls smoothly along rails toward the roaring blade. Every movement is deliberate, the tightening of clamps, the adjustment of angles, and the pull of the long lever all done by hand. When the Bolander saw starts, a deep mechanical hum fills the workshop. The massive vertical blade slices through the log with relentless force, sending a shower of sawdust across the wooden floor. The rhythmic clank of chains and gears echoes between the walls, blending with the earthy scent of fresh-cut wood. Around the saw, the interior tells its own story, shelves filled with blocks of lumber, tools carefully placed, and sunlight streaming through old windows. This is not just a workshop, it's a living museum, where tradition meets the raw strength of early 20th century machinery. The Bolander sawmill in Lingade stands as a tribute to Swedish engineering and the skill of generations who worked with wood and iron. Even today, each cut log whispers of the past of forests, labor, and the enduring harmony between man and machine. This is Sachs Stamo 75 from 1962, equipped with an Eisenman generator. The engine delivers 1.8 to 2 horsepower, while the generator provides 0.8 kVA at 3.65 amperes. Despite its age, the engine runs perfectly without any issues. The speed of the motor is regulated via a mechanical linkage that adjusts the throttle, keeping it steady under load. Its simple yet robust design reflects the engineering of the era, making it a reliable and fascinating example of vintage German machinery.